let A is a set where all real numbers. A belongs to real number except or excludes 3. B is also a set of all real numbers excludes 1, and the function is defined from A to B, and function is x minus 2 upon x minus 3 where all x belongs to capital A. Then show that f is a bisective. The function is bisective means the function is 1 1 and onto, that is function is injective as well as surjective. So we need to show the function whether function is injective or not and the function is surjective or not. If function is injective and surjective, then we can say that the function is bisective. For injectivity, we have to show f of x1 equals to f of x2. We have to take f of x1 equals to f of x2 and we have to show whether x1 is equals to x2 or not. Okay. So let's take f of x1 equals to f of x2. Let's consider this, and from here we have to show whether x1 equals to x2 or not. F of x1 is nothing but x1 minus 2 upon x1 minus 3, and f of x2 is x2 minus 2 upon x2 minus 3. Let's cross multiply it. We will get x1 minus 2 into x2 minus 3 is equals to x2 minus 2 into x1 minus 3. So let's open this bracket. What we will get? x1 x2 minus 3x1 minus 2x2 plus 6, and this is equals to x1 x2 minus 3x2 minus 2x1 plus 6. So here we can see this plus 6 and this plus 6 get cancelled out. This x1 x2 x1 x2 get cancelled. So let's take like term on each side. Let's take x1 to the left side and x2 to the right side. So what we will get? Here we can see it is a minus 2x1. If we take this minus 2x1 to the left side, it will become plus 2x1. This minus 3x1 and plus 2x1 become minus x1. And if we take this minus 2x2 to the right side, then we can see minus 3x2 plus 2x2. It will become minus x2. So minus, let's multiply both sides by minus sign. So we will get x1 is equals to x2. So here we can see by considering f of x1 equals to f of x2, f of x1 equals to f of x2, we are getting x1 equals to x2. So we got x1 equals to x2. It means that the function is injective function. The function is 1 1 function, 1 1 or injective. Now let's check surjectivity. Surjectivity means we need to check the function whether the function is onto or not. So for that, consider fx equals to y. So y is equals to x minus 2 upon x minus 3, and convert this equation, this function, to the x equals to something. This is a y equals to something. We have to convert this equation to the x equals to something. So we are finding the inverse in short. Okay. So what we will get, y into x minus 3 is equals to x minus 2. So we will get y into x minus 3 into y equals to x minus 2. So what can we write? If you take this x to the left side, so yx minus x will be in the left side, and take this minus 3y to the left side, so we can write minus 2 plus 3y. Let's take x common from these two terms, so it will be y minus 1 equals to 3y minus 2. So we will get x is equals to 3y minus 2 upon, and this minus y minus 1, if we take this y minus 1 to the right side, it is multiplied with x. If we take to the right side, it will be goes to denominator, so it is y minus 1. So we got x is equals to something, that is x equals to 3y minus 2 upon y minus 1. So we need to check, for surjective we need to check whether the codomain equals to range or not. For onto, we have to check codomain is equals to range or not. So here we can see x is belongs to A and y is belongs to B. So we can see y is belongs to B, y minus 1. So 1 should not be comes under B. So we can see in a B set 1 is already excluded. So it means that codomain is equals to range, means all values are possible. We can substitute any value for y except 1, because already B, from B 1 is excluded, so we don't have any such value which are undefining the given equation. So we can say codomain means all domain values, all codomain values have pre-images. So y has, we can take any values of y which are belongs to B. It means that codomain is equals to range, because f is already defined from A to B and B is the codomain, and y can take any values. It means that codomain is equals to range. So the given function is 1 1 as well as onto. It means that the function is injective as well as surjective. If the function is injective as well as surjective, then it is a bijective function. So the given function is bijective.